All right, class. So we're going to go over graphs and maps again. And basically what we're going to do is we're going to look at something called a chromatic number. Okay. And I'm just going to kind of go through these exercises with you. Normally in class, we'd kind of like break out, do a drawing, then we'll compare them. But I'm just going to kind of do them, pay attention, take some notes on some stuff there. And you can see what's going on here. And it's pretty easy once you do it. And I'm going to show you how to do this. And one of the things we're going to do is basically solve conflicts with it, whether it's scheduling, time management, anything like that. So here we're going to do some simple things. But first we're going to review what a chromatic number is. So first time we saw this when we were coloring those maps with the states and giving them different colors. Then we try to do them with the few possible number of colors we did than before if we can. And that smallest number of colors is the chromatic number. All right, and that basically says if you have a scheduling problem or a time problem where you have a lot of options, okay, you can kind of link all those options together and then kind of figure out what options can go together and make them one option. Then you have fewer options together. So that's basically the idea. We're going to combine all the possibilities and try to group them together so where we can have only a few possibilities. And that's the main idea. All right, so let's look at this first example here. The chromatic number of a graph is the minimum number of colors needed to color each vertex in such a way that any two vertices sharing an edge are a different color. All right, so basically what they're saying is we're going to put a vertice, draw a line, put a vertice. I like to use C, so C1 is one color. Okay, you can also even say, well, let's say it's red. If you want to label it colors, that's fine. If you want to use colors, that's great. All right, and then C2 would be the different color because since these two vertices are sharing that line, that edge, it has to be a different color. Just like if we had two states here on our map, all right, we'd have one that was one color, and then we'd have to do the neighboring one a different color. All right, so on our graph, same idea, and I can say this one is blue. All right, so that's the main idea of what's going on here. All right, so it's asking us specifically to draw two graphs here that have a chromatic number of 3 and 4. In other words, maximum minimum, or maximum of 3 colors that we can use here. All right, so let's see what we can do. So a graph of 3, pretty simple one. So we'll make one vertex here. All right, we'll make this color 1, whatever color you would like to do. If you like these colors, like I said, you can use different colors. All right, let's put an edge and then put another dot here. That would be color 2, whatever color you decide. And put another vertex, make that color 3, because these will share the same edge. All right, so color 1 can't be color 3. It also shares an edge with color 2. So all 3 of these vertices have to be a different color. All right, and then we're going to go into another one. This one's going to need 4. So if I draw a vertex here, make a little box. All right, 4 vertices. All right, draw an edge there, down, complete my box. And let's do our diagonal, and then let's do a loop around to this one. All right, so let's start at this top left vertex. So let's say that's color 1, shares an edge with this vertex on the right. We'll say this is color 2. All right, color 2 shares a vertex with this one here on the bottom right, and this will be color 3. All right, now normally we could, if we didn't have this line here, we can make color 1 and color 3 the same color because they don't share an edge, right? But we need to have 4. All right, so what we're going to do that is make that edge there. That's why I drew it. And that forces us to be a different color because this vertex now shares an edge with color 1 and 2, so we need a third color. And this other one here shares a edge with 3, 2, and 1, so we would need a different color here, so a chromatic number of 4. So this one here is our chromatic number of 3. And this one here is our chromatic number of 4. All right, so 4 number of possibilities, the minimum amount of possibilities you can use, which will maximize efficiency. I guess that's a better way of saying it. All right, so let's try this next example here. Give an example of a graph that has 20 vertices, that has a chromatic number of 2. All right, so we got to draw 20 points, and we can only use 2 colors. All right, and there's many ways to do this, but I do like a tree type thing. So let's put one vertex here, and it breaks off into 2. Then these 2 will break off into their own two, something like this. So you'll have this like little tree thing going on here. All right. And this is what's going to be one color. So this will be color 1, and since it shares a vertex with these, since it shares an edge with these two vertices on bottom, these got to be a different color. But since these two vertices that are on this level, so you can think of it like this: level 1, this is level 2, this will be level 3. All right, since they don't share, these can be the same color. So these both can be whatever color you choose. Top one red, second level green, whatever. All right, and it kind of goes the same thing here. Since these 4 bottom vertices on level 3 don't connect with level 1 as an edge, these can be color 1. All right, so these can all be the same color. So in other words, if you made this one red, like I said, all of these ones here can also be red. All right, so that's an example of having a chromatic color of 2. Write that out real quick. All right, and we only need 2 colors to do that. So we just alternate color 1, color 2, color 1, color 2, all the way down until we draw 20 vertices. I'm not going to waste time doing that. All right, so let's look at something that's going to be relevant to the assignment you're actually going to do. So here's a scheduling problem. We have some classes. We've got to make up a schedule here. All right, and to save time, I already wrote out the schedule here, so I'm just going to kind of explain it. All right, so Ms. Jacobs, the new principal at Riverdale High School, wants to make a good impression by offering a lot of new exciting classes for her students. The principal plans to use her knowledge of graph theory to determine when each class will be offered. All right, since she is trying to make her students happy, Ms. Jacobs does not want to offer 2 different classes at the same time if there are students wanting to take both. All right, so she decides to construct a graph in the following way. Each class is represented by a vertex, and there is a student interested in 2 classes. Those 2 vertices are connected by an edge. All right, so you know what? I think I am going to go ahead and just construct this, and I'll just show you how I came up with this thing here. All right, so let's do this. All right, so suppose there are 5 classes, A, B, C, D, E. Okay, only 5 students wishing to be taking the following classes. So we got each student here by name: Jason, Emery, Felicity, Jeff, and Hillary, or Gian. Nothing is Jeff, whatever. All right, construct a graph for the principal. Okay, so this is what we're going to do. All right, so we're going to put our classes down. So let's start with class A. All right, so put a vertice. I'm going to label this A. Okay, it's class A. And Jason wants to take classes A and E. So we're going to put an edge from A to E. All right, that means one person is interested in that, so it gets an edge. All right, Emery wants to take classes B, C, and E. All right, so now we need a B. Just put a B somewhere. We need a C somewhere, so I'll just put it there. All right, so you can literally put it anywhere. All right, but now let's look what needs to happen here. All right, so she wants to have B, C, and E. So B needs to connect to C. B also needs to connect to E. C needs to connect to E. All right, so see how our graph is constructing here. And we're just going to keep going through each person. All right, so Felicity, she wants classes A and D. So now we need a D point. Let's put it here. All right, we'll label that D. All right, so she wants classes A and D. So we're going to loop around and create an edge from A to D for Felicity. All right, Jeff wants to take a class B and C. All right, well, we already have that edge, so we don't need to do anything there. It's already an option. Haley wants to take classes D and E. All right, so there's no edge from D and E, so we need to make one. Bam, there it is. All right, and there's that graph I had from before. Okay, so now I need to see how can I give these things colors and find a chromatic color for it. All right, so and this is going to help me answer the questions here, and I think I deleted part of one. There should be 3. Okay, so what we can do is say, all right, let's start at A. We'll say this is some color 1. We'll do a different, so we'll say color 1, right? Okay, and since A is connected to E and D, those cannot be color 1. All right, so get B. So B is safe to be color 2. Color 1, right? Because B doesn't connect to A at all. So we can use that same color there. All right, but B connects to C, B connects to E. All right, so C and E can't be a color there at all. So what we can say is C has to be a color 2. All right, since C color is connected to B, which is whatever color 1 is. So C can't be that color, and then also E can't be that color as well. All right. So let's go to E. So since E is connected to color 1 from A and B, and it's connected to color 2 from C, we have to give it a different color. And this will be color 3 right there. All right, so there is color 3. Okay, and I'm just going as I look at my graph, so it might be slightly different from what was up there earlier. So like I said, just go through it one by one. All right, just make sure whatever vertex is not the same color if it's connecting to another color. All right, so far we're good. All right, and then since D does not connect to C at all in any way, this one can share the same color here, so this one would be color 2 as well. All right, and for some of y'all may actually help to actually do different colors, but there it is. And since I'm only using 3 colors, the reason I like to do C1, C2, C3 is because that gives me the chromatic number. And in this case, find the chromatic number of the graph, color the graph, those numbers, colors, okay, chromatic number is 3. All right, and there it is, okay? So we just took all these possibilities from these students and got it down to 3 main cases here. All right, so let's continue on to next one. So how can the graph coloring solution help the principal with her scheduling problems? Well, since we have 3 colors, that means she's gonna have to have 3 separate periods throughout the day, okay, that don't have time conflicts with these students, so they can take both if they wanted to, right? Okay, so basically you're gonna say, okay, well, period 1 would be whatever class, the same colors, classes A and D. So let's do that. So C1, A and B. So since C1 are the same color, we'll say, okay, first period will be classes A and B. All right. Period 2, okay, let's use color 2. Those would be classes C and D, right? Because there's no schedule conflict there. And then period 3 is all by itself over there. So period 3 we will offer class E. All right, and there we go. So all the students would be satisfied to take both classes, all 3 classes that they wanted to, and it will solve your problem there. So you're going to do this very similar thing with chemicals, but be careful that you read the questions because it wants to know which chemicals should not be together. All right, so I'm just going to kind of give you a hint here. So if you have something like chemical A cannot be with chemical B, you're going to want to be very careful to realize that whatever chemical A is, there's chemical B. When you draw that edge, that means they cannot be together. All right, so be careful with that wording there. And that's the hint for the assignment.